Okay, welcome back to another video lecture for section 1.4. We're in unit 2, talking about quadratic equations and the different ways that we can solve quadratic equations. Now this is one of the more important sections in the entire course, so I do encourage, as you're watching this, do it once for the video check, and then of course go back and watch this video as many times as you need to in order to understand the techniques that are presented in this section. So in this section, it's all about solving quadratic equations. I'm not going to waste an awful lot of time talking about where these types of equations occur because, as you no doubt will see this year, these things pop up when we try to solve many, many different forms of equations, and so we have to have a technique for dealing with them because of how common they are. So to begin with, what is a quadratic equation? A quadratic equation is anything that has a quadratic term, and what I mean by a quadratic term is that it has an x squared term in it. So the specific term in this expression here that is causing it to be quadratic is this term right here, ax squared. The fact that there is an x squared, a second power, a second degree, this is what is turning this thing into a quadratic equation. It's important to note that quadratic equations have two solutions. They may have the same solution two different times, which we call multiplicity, and you'll see that periodically, but it doesn't happen all that often. I'm going to show you what that means graphically as we come to it in class. I may or may not get to it in this video. So in a quadratic equation, we always want to write these things as ax squared plus bx plus c equal to 0. And it's really, really important that we have these equations in standard form because almost all of our solving techniques, with one little exception, will involve the standard form of the quadratic equation. So if you see that there's extra stuff on the right-hand side of the equation, or it doesn't look like this, you need to do a little bit of rearranging, maybe changing a negative to the addition, changing a minus sign to the addition of a negative so that you can reorganize this thing so that it looks like our standard form. So that's the first and most important step, is turning it into the standard form. And then we need to have a way to solve from there. There are 5 ways to solve that we will cover in this course. And some of them are really, really easy if they're nice and simple expressions that you can create a graph for on your TI calculator, and then of course you can look at them and it's pretty easy to find a solution for. Some of these, on the other hand, are not as easy, and so I'm going to draw your attention to some places in the calculator, and of course you're going to pick whichever way works the best for you in order to solve these things. So a couple of different ways. We have factoring. This is one of the most important skills that you can learn. It's this first little orange dot over here. Factoring is sometimes called the zero products property in Pearson, so it's important to note that if it says use the zero products property to solve, they want you to factor this thing. Now Pearson can kind of be gamed a little bit because you very realistically can take any quadratic equation and you can solve it using things like the quadratic formula, which of course you've talked about in your high school courses before you've reached this point. That being said, try to do it the way that Pearson wants you to do it. It's good for developing your skills, but if you get to that point in the homework where you're just like, I don't know how to get an answer for this thing, I do want you to know that this quadratic formula is always available to you if you can put it in the standard form, and that's the most important thing. First thing and most important thing. So secondly, we have completing the square. This is a nice skill to have. For the purposes of college algebra, if this is your terminal point in mathematics, you can kind of skip completing the square because frankly, its uses are very minimal compared to things like the quadratic formula. If you are going to go further in mathematics, example, you're going to take calculus at any point, or pre-calculus, or anything higher than college algebra, you need to understand how to do completing the square, or at least have been exposed to it before. So I will do a couple of example problems using completing the square, and it is important that you go back and rewatch these if you're going further. If you're not going to go further, you know, quadratic formula is perhaps the most straightforward way. We have a nice formula which you plug some numbers into and it gives you the answers. That's all there is to it. We do need to make a quick note that when you attempt to do this on the calculator, your calculator has to be in a special mode in order to get both of the answers. Now, other 2 ways that we can solve are graphing and symmetry. The symmetry thing is going to be brand new to almost all of you. It is one of my favorites, and I could be convinced to maybe do some bonus points if I see that you're solving problems this way consistently. Graphing is extremely straightforward. Most of the time, you are going to graph these things anyway just to see if it's an easy problem where you can just pick out the two special points, which are the solutions. And if it happens to not be one of those nice and easy points, like the answer is 3 or the answer is 4, then of course you need to go through your list of other ways to solve it. Now, I'm not going to spend a lot of time on graphing in this video because graphing is extremely easy. If you need some help on this, I suggest a plus time or watch one of the supporting videos that I will be making later throughout the course and uploading. I'm not going to put them necessarily as a video check, but be watching the YouTube channel and make sure that you understand how to do this if a supporting video comes up. Okay, so to begin with, we want to solve some of these things by factoring. And I just want to kind of walk you through the solving process because that's all that this section is about. Can you solve a quadratic equation? So here I have a quadratic equation, x squared minus 7x plus 12 is equal to 0. And we want to first check to make sure that the quadratic equation that we have is in its standard form. I should probably also show you that the reason I know this is quadratic is because it contains an x squared term, and then everything underneath it is of lesser degree. That means the exponents are all smaller or non-existent. So I have x squared, x to the first power, and then I have no x term over here. Okay, so once I've established that this is quadratic, I need to check to make sure it's in standard form. Easiest way to do that is just to see that the x's go in descending order, x squared, then x, then a constant. This one does. And furthermore, we want this first term here to be positive, if we can make it positive. So this is a positive 1, that means we are good to go, we're ready to solve this thing. Okay, so when we factor this thing, what we're trying to do is break this into two smaller binomials that will multiply to give us this result, because factoring allows us to use linear equations, which at this point we've had a whole unit about and we know how to solve them. When I factor, I'm going to get two parentheses, two binomial terms, multiplied together, equal to the same thing that the original quadratic was equal to, in this case 0. So the way that we factor, we're going to pretend for a second that the term that made it into a quadratic, we're going to write that term down twice, but we're going to ignore the index. That means I'm not going to write down squared, I'm just going to write what I see if I ignore this exponent right there. So I'm going to write down an x because that's what I would see if I covered up the exponent. The next thing I'm going to do is I'm going to multiply the coefficient of the first term, coefficient of the quadratic term, by the constant. So that's a 1. This is understood to be 1. 1 times 12 gives me 12. And you'll notice that I've written that down as 12 comma 1. What I'm doing is I'm going to list all of the pairs of numbers that can be multiplied to make 12. And these need to be positive numbers. So 12 and 1, 6 and 2, 4 and 3. The next thing I need to do is look at this middle term right here. I see negative 7. And what I'm going to try to do is I'm going to make that number by either adding or subtracting the number pairs. So for example, 12 plus 1 is 13 and 12 minus 1 is 11. That's not 7, so I know that this is not the correct number pair. 6 plus 2 is 8 and 6 minus 2 is 4. That's again not the correct pair. 4 plus 3 is 7, so I know that that is the correct number pair. I'm going to write down a 3, I'm going to write down a 4. Now, at this point we can kind of play a common sense game. We can say, okay, how do I make negative 7 using a 3 and a 4? Well, negative 3 and negative 4 together makes 7, and that's how I know what my symbols have to be. There are some tricks that you may have learned. I'll briefly state them. I don't really use these tricks, I kind of common sense them. But if you look at the bigger of the two numbers, it always agrees with the symbol in between the quadratic and the linear term. And then if you look at the symbol in between the linear and the constant, which is this one right here, if it's a plus sign, both parentheses match each other. And if it's a minus sign, both of the parentheses are the opposite of each other. So you can think of it like this one tells you what the bigger number does, and then this symbol tells you whether they match or they don't. So there's lots of little tricks like that that you can use. Okay, at this point, what we need to notice is that I have two numbers times each other, and they're equal to 0, which is very, very important. So what does that tell us? That tells us either that x minus 3 has to be 0, because if this number is 0, then the whole product is 0. It doesn't matter what that number is. or it tells me that x minus 4 is equal to 0, and then of course if this number is 0, it doesn't matter what that number is, the whole thing is 0. So at this point we can do some very easy things to solve, and of course these are nice easy linear equations, so I'm not going to waste time showing you how to do that. I'm just going to write down the answer. X in this case is either 3 or 4. In other words, it comes out of this set right here. That is our solution set as we would need to write it in Pearson. Okay, moving forward. This is what I'm going to call the easy case. I call this the easy case because the leading coefficient happens to be 1, and furthermore, it was already in the correct form. Let's take a look at example 2. Example 2, first of all, I can identify that I have a quadratic. I know that because this term right here is x squared, and then every other exponent underneath this is smaller than 2, so the biggest exponent is a 2. Furthermore, it's already sort of in the correct form, but notice that it is not equal to 0. So it's super, super important to note that in this expression here, it has to be equal to 0 in order for us to solve it. So put a star by it or make a note of it in your notes, however you need to remember this. So when I see that this is equal to 1, the very first thing I need to do is make it equal to 0. I can do that by taking 1 from both sides, which has the effect of canceling the 1 off of the right-hand side, turning it into a 0, which leaves me with 10x squared plus x minus 2, and this is a quadratic equation in standard form, which we can now attempt to factor. So again, what we're going to do is we're going to attempt to find two binomials that multiply to make this original expression, 10x squared plus x minus 2 equals 0. Those two binomials will still be equal to 0 since this factored form is the same thing as that, it's just a different way of writing it. And then remember what we did right here. I'm going to look at the quadratic term, pretend like I've covered up the exponent, and I'm going to write down what I see. If I cover up the exponent, I see 10x, so I'm going to write 10x twice in both of these. Next, what I can do is multiply the leading coefficient by the constant, the same thing I did right there. So 10 times 2 will give me 20. And then remember, I'm listing pairs of numbers that multiply to make 20. And I want to try to do all of these. So I have 20 and 1, 10 and 2, 5 and 4, and if you have others, then of course you can do those. Now what I want to do is I want to look at the middle number right here. Again, remember this is the same as the little pink underline up in example 1. And this is an understood 1. I want to try to make a 1 by adding or subtracting those number pairs. 20 plus 1 is 21, 20 minus 1 is 19. It's very, very obvious that that's not the correct pair. 10 plus 2, 10 minus 2, again, it doesn't make 1. 5 plus 4 is 9, but 5 minus 4 is 1, and that's important. This is the correct pair right there, that 5 and 4. So immediately I'm going to write down a 5, and I'm going to write down a 4. So how do I make positive 1 with a 5 and a 4? Well, I need a plus 5 and a minus 4. So add 5 and take away 4 gives me 1. The next step that I'm going to do is a very, very important one that is often skipped. When the leading coefficient here is not a 1, we have to remember to do this step at this point. So what I'm going to do is I'm going to look at each parenthesis separately. 10x plus 5. And I'm going to say, what is the greatest common factor in 10 and 5? And once I've identified what that greatest common factor is, I have to divide both numbers by it. 10x and 5 have a greatest common factor of 5. So when I divide 10 by 5, I get 2x. When I divide 5 by 5, I get 1. So that leaves me with 2x plus 1. Over here, 10 and 4 have a greatest common factor, which is 2. So dividing 10 by 2 gives me 5, and dividing 4 by 2 gives me 2. Now remember, this is equal to 0. And at this point, we have our two cases. Either 2x plus 1 equals 0, or 5x minus 2 equals 0. And again, these are linear expressions, so I'm not going to waste your time solving both of these. I'm just going to write what the answer is. You can attempt to solve these on your own. So the answer here is that x is either negative 1/2 or positive 2/5, and I encourage you to try to solve this to verify that that is the correct answer. Okay, let me clean the board up. I'll be back with some more examples. All right, now in the next example here, as I've cleaned up the board, I've written kind of a funny looking problem. Again, remember that these things have a tendency to be presented sort of out of order sometimes just to try to confuse you, but you don't have to be scared by it. First step is always identify what you're looking at. This is quadratic because of this term right here. It's the biggest exponent and it happens to be 2, so this is quadratic. Now notice that our standard form is in descending order. This one is backwards. You have the constant first, then an x term, and then a 3x squared term. All I need to do is rearrange these terms to make them look like this, and then I'm good to go. So if I rewrite this thing, I'll have positive 3x squared, I'll have negative 26x, and then I'll have positive 40 is equal to 0. Notice that that's very easy to do. Okay, next step. I'd like to factor this, so I'm writing 2 parentheses, 2 binomial terms that multiply to make this thing. I start by covering up the exponent and saying, what do I see? Well, I see 3x, so I write 3x in both spots. Next, I'd like to multiply the leading coefficient times the constant. That's a 3 and a 40. That gives us 120 and 1. Now here is an important thing to mention. If you remember back to your test taking days for the STAR test, what you may want to do is use those calculator tricks that you were taught for finding factors very quickly. You type in 120 divide by x and y equals, and then you use the tables to list all of these, because this list gets pretty long pretty fast, as I'm sure you'll see. But what we're looking for are numbers that make 26, so you may be able to skip some terms if you know for a fact that they don't work. For example, 60 and 2, I really don't need to write that, because if I write 60 and 2, you'll know that that's 62 or 58. It's not really going to help us, so I can just kind of ignore that. In other words, I'm only going to list ones that I think might potentially be the case. I'll go ahead and list all of them for now so you can just see, but as you get better at this, what you'll see is that you don't always have to list every single one of these. So you have 60 and 2, you have 40 and 3, you have 30 and 4, and then you have a list of some others that come afterwards. Now what you'll notice here is that I need to make a 26 by either adding or subtracting numbers. None of these 3 pairs work, but 30 and 4, 30 minus 4 is 26. So I'm going to write 30 and 4. Now, how do I make a negative 26, which is this term right here, with those 2 numbers? Well, first of all, I need negative 30 plus 4, which will make negative 26. Then I need to attend to the last step, which is I look at each parenthesis separately. And I'm going to say, what is the greatest common factor in the terms? So 3x minus 30, they have a greatest common factor of 3. So I'm going to divide both terms by 3, leaving me with x minus 10. 3x and 4, those are co-prime numbers. That means they don't have a greatest common factor greater than 1. So I just leave that term alone. Now, my 2 cases, I've got x minus 10 equals to 0, or I have 3x plus 4 equal to 0, which means that x is going to either be positive 10 or it's going to be negative 4/3, and that is my solution set right there. Okay, I'll come back with some more examples. Okay, not all equations are factorable. And as you can probably guess from our procedure, you see that we multiply the first term times the constant, and that gives us pairs of numbers that multiply to make some new number. For example, in example 3, it was 3 and 40, which made 120, and then we started listing pairs of numbers that make 120. If you cannot find a pair of numbers that adds or subtracts to make the number in the middle, all this is telling you is that factoring is not the correct procedure for finding the solution. So we want to look at a couple of cases where it might be necessary to do something maybe a little bit different in order to find a solution. So here is one of the most easy cases, and this is when you simply have something squared equal to something else. Now, most of you learned in Algebra 1 and Algebra 2 that the way that you undo something is you do an inverse operation for it. For example, if I add 4 to something and I want to cancel that 4, then what I need to do is I need to subtract 4. If I multiply 3 by something, I need to divide 3 to cancel it out. If I square something, I need to take a square root in order to cancel out the squared part. So when you simply have something squared equal to something else, Why don't we just do that? It's going to give us an answer anyway. So if I take a square root of both sides in example 4, the square root of x squared is just x, and the square root of 29, well, we can try to simplify this with our factor trees like we did in 1.3. We can type this into the calculator to get a decimal approximation. There's a bunch of things we can do. But what you're going to notice is that this doesn't simplify and it doesn't have a perfect square root, so it's easiest just to leave it as the square root of 29. 29 is prime. Okay? But we also discussed that quadratics have two solutions. So when you use this property, it is important that you remember that there is both a plus and a minus version of this. If you have to introduce a square root to the equation in order to solve it, do not forget the plus or minus. And that is true for all of these. Okay, second example, I have x squared equal to negative 144. Why don't we just do what we did in example 4? I have x squared equal to something else. Let's take a square root of both sides. Square root of the left-hand side will cancel the exponent, leaving us with x equals. Square root of the right-hand side, I'm going to go ahead and write it down just so we don't forget. We'll have plus minus the square root of negative 144. Now we have to think back to 1.3 for a second. We know that the square root of a negative is going to generate one of those complex numbers where we have to use I. So the very first thing I'm going to do is I'm going to erase the negative on the inside, and I'm going to write I out in front of it to remember that this is a complex number. Now I have the square root of 144, and if you type that into your calculator or you just remember your squares really well, you will notice that this is 12. So what I have all in all is plus or minus 12i, and that is my solution set. Example 6, I have kind of a complicated looking term, but I do want to show you something that can be useful. You might look at this and get scared because it says x minus 8 quantity squared is equal to 24. But if you look at this orange underlined part right here, what you actually have is something squared equal to something else. So since it's something squared equal to something else, that's the exact case where we can simply take a square root of both sides. Let's go ahead and do that. As I take a square root of the left-hand side, remember the effect here was canceling the exponent out, so that's exactly what's going to happen here. It's not going to touch the x, it's not going to touch the minus 8, it's only going to cancel the exponent out. It is important to note that the only reason that this works on this example is because you have a parentheses around this and then the whole thing is squared. If this was x squared minus 8, you cannot just take a square root of both sides. That's not okay. The whole thing has to be squared. And it can't be plus or minus something on the outside of the squaring. In other words, if you don't have a parentheses with it squared, don't try this. So square root of a square leaves us with x minus 8. And then the square root of 24, I can quickly come over here and just make myself a factor tree. I know that 24 is 4 and 6. 6 is 2 and 3. I'm going to cross off the 6 at this point. And then 4 is 2 and 2. I'll cross off the 4. So I'd like to take pairs of numbers outside of the square root symbol. And I can see that I have a pair of 2's and then I have a 2 and a 3 left over that can't go outside of the square root symbol. So what I'm going to have is 2 root of 6 on the right-hand side. And of course I should remember that this is plus or minus. So when I solve this thing, I currently have x minus 8 equals plus minus 2 root of 6. And if I want to get x by itself, I can do that by adding 8 to both sides. This will have the effect of canceling the 8 off of the left-hand side, leaving me with just x. And on the right-hand side, you need to be careful here, because I have 2 times the square root of 6, and I don't know what that number is off of the top of my head. That means I can't just add an 8 to the 2 because it would change the end result. I have to add 8 to the number 2 times the root of 6, and since I don't know what it is, I'm just going to write 8 added or subtracted to 2 times the square root of 6. And that is the solution. You get this kind of nasty looking thing, but that's totally fine. Pearson accepts it. Okay, I'll be back with some more examples. Okay, so we've looked at equations which are factorable, You can use the zero product property to solve them. We've looked at equations that are not factorable, but they're easy because it's just a number squared equal to something else. We can use square root property in order to solve those. What about expressions like this that don't really look like they're going to be very easy? If you think about this, first of all, it's quadratic. Second of all, it's not in standard form. I can rewrite this, x squared plus 6x minus 3 equals 0, and now it's in standard form. But if you think about factoring this, you've got 1 times 3, which is a 3 and a 1. Those are the only numbers that make 3. And then 3 plus 1 is 4, and 3 minus 1 is 2, which is not 6. You can't factor it. Furthermore, it's not just x squared equal to something else. It's x squared and then another variable term, which makes this a little bit more difficult to handle, and I still have to come up with an answer for it. When you get into this situation, my suggestion for the purposes of college algebra is always rely on your quadratic formula if you can. It's nice and easy, or rely on the symmetry method that I will show a little bit later in the video. We need to recall first that the solution to any quadratic in standard form equal to 0 is that x is equal to minus b plus or minus the square root b squared minus 4ac all over 2a. And if you recall, I had written the standard form over here where this is a, this is b, and this is c, so we just type in the numbers that we see and this gives us our answer. So if we want to set the quadratic formula up for this thing, we notice that this thing here, 1 underline, this is a, it's understood to be 1. Double underline is b, and triple underline is c. So writing this thing out, x will be equal to a negative of b, and we get the negative from the formula, and then we write the number that we see here, so that's negative 6, plus or minus the square root of b squared, well 6 squared is 36, minus 4 times a, which is 1, times c, which is minus 3, all over 2 times a. And it's important to note here that when I plugged c into the formula, I also paid attention to what the sign was in front of it. So if this is negative here, you get a negative from the problem. And if you get a negative in the formula like this, you get 1 negative from the formula and 1 negative from the problem if you have that. Now all I got to do is get in the calculator and type this thing out. It'll give us 2 different answers. I do want to also point out that you notice when we were using the square root property, we got a plus minus. One of the reasons we get the plus minus, if you look at your quadratic formula here, you can just accept that the plus minus in the square root property is the same as the plus minus in the quadratic formula. 2 different answers. In your calculators, if you have one of mine from the school, we have a quadratic formula program. You can use this to simplify doing this very, very quickly, and you can get answers relatively easily. You do need to be in a special mode if you have a complex answer, so sometimes you might get an error. And if you get that, then I need you to actually do this until we get to some of the later videos, and then of course I'll talk about how to put the calculator in the correct mode, and that will simplify your life. So on this second one, part B, we notice that we have 4x squared is equal to 3x plus 5. And I want to show you one little thing. You might be saying, wait a second, this is just x squared equals to something else, so why can't I do a square root? If you do a square root, notice that we get a single x on this side, but we get an x inside of a square root symbol on the right-hand side, and then there's no amount of combining like terms that I can do that will simplify the equation, so you actually make your life harder if you do that. If it's a single x squared in the problem and then a bunch of numbers, of course use your square root property. This, however, we need to use our quadratic formula. So rewriting in standard form, 4x squared minus 3x minus 5 equals to 0. Setting my quadratic formula up, where again this single underline is A, this double underline is B, and this triple underline is C. So I will have negative of B, and here we notice that we have negative 3, so you see I have negative 3. It's kind of weird to have double negatives, but we get those sometimes. Plus or minus the square root of negative 3 squared, well, it's negative 3 times negative 3, that's 9, minus 4 times A, which is 4, times C, which is minus 5, all over 2 times A, which is 4. And this one I'm actually going to simplify out for you. Notice that we have a double negative here, so we're going to have that x is equal to 3 plus or minus the root of 9 minus, let's see, this is 20, and then 20 times 4 will give me 80, so this is 9 plus 80 total, so that's plus 89, all over 2 times 4, which happens to be 8. Now, we can, at this point, we can take the square root of 89 and see if we can simplify it. One other nice program that we have in the calculator to see if there's a possible simplification for it, you can hit the program key and you can find the program that's called prime FAC. That stands for prime factorization. It will actually do your factor trees for you, and then that way you can come up with your answers very, very quickly. Of course, you do need to know how to do these on your own, but if you just need to do a simplification pretty quickly on a quiz or a test or something, please make use of the calculator programs to do these a little bit quicker. But, provided that this doesn't simplify, that is your solution. That's all there is to it. I'll be back with just a few more examples. Okay, in this last example, I'm going to show you a nice symmetry property that we can use to solve quadratics relatively quickly. Frankly, I think that if you are not very comfortable with your calculator programs, or you're not very comfortable with your quadratic formula, or some of the other properties, this is honestly one of the best ways to do it. It's also going to be new to most of you. I am only showing one example with this because I have shown so many others, but just keep in mind that this is one of the nicest ways to do these. So in order to do this method, what we need to know is that we need a quadratic in standard form. That's 6x squared plus 5x plus 1 equals to 0. Most of you are going to say, hey, wait, we can factor this, and yes, of course, you can factor this and it's faster, but I'm doing that just so that you can very quickly verify that what I'm saying is true. So the next thing we want to do, if you're going to use the symmetry property, we want to take the first number, the leading coefficient, the 6, and we need the leading coefficient to be 1. So what I'm going to do is I'm going to divide everything by 6. Now some of you have already turned off because you see fractions and a lot of you don't like fractions. Well, guess what? Fractions are a realistic part of college algebra, and if you use your quadratic formula, you need to be familiar with simplifying them. The reason that I get my fractions early is because I don't want to simplify them later in the quadratic formula. I think this method is very nice about that. So you get fractions early, but it doesn't get much worse than this. The next thing I'm going to do is I'm going to write down what the answer is. And I'm going to write that down because of a feature of the graph. If I have a quadratic expression, it makes this nice parabola shape. Now, things that we should know about this parabola shape is that we have an axis of symmetry right here, which is connected to the x-coordinate of the vertex. And the next thing you need to note is that any sort of horizontal line that I draw on this thing has this nice property that the distance on the left and on the right are identical to each other. So all I need to do is find where the vertex is and then go some kind of special distance to the right and the left. In other words, I'm adding and subtracting the exact same number on the right and on the left to find what the zeros are. So the vertex, which you will learn throughout the semester, and you probably should recall this from geometry and maybe algebra 2, the way that we do this is we're going to take a negative version of the number b, and we're going to take half of it. So if this is a whole number, halving it is very, very simple, and most of you can do that. If it's a fraction, what that means is double the bottom. Okay, that's half of a fraction, you just double whatever the bottom is. So that's minus 5 over 12. Then I'm going to write down plus or minus in this little u thing. So notice that this is actually two different binomials. It's negative 5/12 plus u and negative 5/12 minus u. If I know that what I'm looking for is a number whose product is 1/6, because that's what happens when we multiply out our binomials, and whose sum is 5/6, then we know exactly what this thing has to be equal to. It has to be equal to this c term right here. So then what I'm gonna do is I'm just gonna FOIL this thing out. I've got two binomials, I'm gonna FOIL it out and I'm gonna solve it. So if you notice what I have here, this is negative 5/12 times negative 5/12. Well, that's double negative, so it's positive. 5 times 5 is 25, 12 times 12, 144. Then you'll notice I have plus u times negative 5/12, which is minus 5/12 u. And then I have minus u times minus 5/12, which is plus 5/12 u. So I have a minus 5/12 u and a plus 5/12 u. In other words, it goes away. Some of you might have already recognized that this exact setup is a difference of two squares, as you might have learned in Algebra 2. So we can shortcut the FOILing process. What we do is we square this number, negative 5/12. The square of that number is positive, 25 over 144. We write down minus, and then we write down u squared equals 1/6. Now I need to take 1/6 and I need to make it into 144. Okay, so I need to take 1/6, make it into 144. And the way that we can do this is multiplying the top and bottom times 24, because 24 times 6 is 144. And then in order to keep the fractions equivalent, I have to multiply the top by that number as well. Now I just need to do some reorganizing here. If I add u squared and I subtract 24 over 144, that will have the effect of canceling the u squared off of the left and moving it to the right and making it positive. And it will cancel the 24 1/44ths off of the right hand side and subtract it from 25 1/44ths, which will make 1 1/44th. That's equal to u squared. This is square root property at this point. We can take a square root of this, and I'm not going to include the plus or minus because the plus or minus is already included right here. So if I take a square root of this thing, what I will be able to see is that u is equal to 1 over 12. Okay? What does that tell us? That tells us that I need to take this 1/12 and substitute it into where I wrote the answer down earlier. And you notice that I said I'm going to write the answer down. I literally wrote the answer down, I just didn't know what u was yet. So 1 over 12, now I just need to finish the expression here. X is equal to negative 5/12 plus or minus 1/12. Okay, so that means negative 5/12 plus 1/12 will be negative 4/12 or negative 1/3. And negative 5/12 minus 1/12 will be negative 6/12 or minus 1/2. And then of course you can verify that this is true by factoring this thing. This is another procedure which is a little bit lengthy, but it does always work in case you have forgotten your quadratic formula or you just want to use paper pencil methods. This is always very, very nice because it keeps you from going into the calculator and doing things and then potentially miskeying and getting the wrong answer. And this thing always works. There is a proof for it. I will do a video, a supporting video later on that will prove that this does in fact work, always. So, that being said, if you can do these things, you've got section 1.4.